In this lab, we're going to use the Dray data that we collected at Kapahau Park and around the CMO campus to estimate population densities of gray squirrels. So here is the open Excel spreadsheet, and if you look at that spreadsheet, you can see that we have a total of 4 transects, transect A1, A2, B1, B2. Those were the transects that were performed at Kapahau Park. C1, C2, and then D1, which was broken up into a couple of different segments because it was along Alta Vista Drive and that street bends around a bit. And then D2, which was the straight part of that transect. Here are the distances. So these X and Y coordinates, those are the UTM coordinates that were recorded for each. They may not be exactly what you have written down in your notebook. I went back later. Remember, my GPS unit, the batteries died. I went back and re-recorded those, and those GPS units are accurate within a couple of meters or so. They're not perfectly accurate, and depending on weather and all of those sorts of factors, those numbers can change. If you really want accurate UTM coordinates, you have to do something that's called UTM averaging. So you have to take repeated measures within a few minutes, and it will then compute a more precise average, and that average is going to be within a meter or so of the true point. But at any rate, here then are the computed lengths of those transects. So A1 was 378.7 meters long. So this value is recorded in meters. 262.8, 403.4, and so on. For D, it's the number in bold here, which is the length of the D1 transect, so 282.9 meters. And then D2 is 273.2 meters. Now here are the numbers for transect A1. And the values that we're concerned with are this angle right here and then the distance in yards. So all of these angles are going to be between 0 and 90 degrees. So there was some geometric manipulation going on here to try and get to that value. We don't have to concern ourselves with that. And then this is the distance in yards. So here we right away have a conflict. This value is recorded in meters. This value is recorded in yards. As scientists, we always want to make sure that we're using SI units. So we're going to concern ourselves with hectares, kilometers, meters, centimeters, and so on, rather than yards and acres and miles and things of that sort. So we can leave this as it is for now. Fortunately, within program distance, all of that stuff will be taken care for us, so we don't have to worry about that at this point. So here are all of the angles and distances for transect A1, A2, B1, B2, C1, C2, and then D1 and D2. So all of the data you need are right there. Okay, I've opened up program distance. This should be version 7 point whatever. On the previous video, I show you how to download it, which website to get it from, and so on. So if you don't yet have program distance on your computer, go back and revisit that other video and try and get the instructions there. It's pretty straightforward. But we've opened the program now, and what we're going to do is come up here and click on File, and we want a new project. So we're going to select New Project. That then is going to open up a series of menu items that we're going to have to work through, and I'm going to show you that. It's pretty straightforward. So here I'm going to give this a name. So Drays 2021. And that's going to be saved as a distance project. So I'm going to create that. And now we have a series of menu items that we have to work through. And in particular, if this is your first time, it's important to pay attention to what's going on here. There is a little help tab over here if you're running into difficulties. But I think if you just follow along with what I'm doing, you'll be good to go. The first option here is analyze a survey that has been completed. That's correct. So we're not trying to design a new survey or simulation. So we're not going to use an existing project as a template or anything of that sort. We're just going to go right along with analyzing a survey that's already been completed. So click Next. Okay, so if you have selected to set up the project file ready to analyze a survey that has already been completed, right? That's fine. Don't show that introductory screen again. No, we'll go ahead and I'm going to keep that unclicked so that the next time I teach this class, I can just go through the same sequence for you. So I'm going to click Next. All right, so type of survey here at the top, we have a couple of options: line transect, point transect, or Q count. We did a line transect. A point transect is a little bit different. That's where you go to a specific point and you wait there. For example, people that do bird counts will oftentimes do point transects. That is, they go to a specific point, they stand there for a certain period of time, they record all the bird calls that they hear or all the elk that they see or whatever it happens to be, and they may record the distance if it's elk or something. If it's a bird count, they're just going to record the presence or absence of the birds. All right, so observer configuration, single observer or double observer. We're going to make our lives simple. We're just going to leave that as a single observer. So we're going to pretend that everybody was acting as just one observer. And in most of the circumstances, if you ever work with this, unless you're on a team or something, you'll be doing this in a solitary fashion anyway. So now distance measurements. Did we record perpendicular distances or radial distances and angles? We recorded radial distances and angles, and this is important for the following reason. There are some statistical problems that arise with the way we perform these transects, and the issue is that our data are not going to be normally distributed, even though we're going to pretend that they are. This is an issue with this particular program and all of these sorts of transects. Ideally, we would want to measure perpendicular distances, but that is clearly not feasible under these circumstances. The problem is that the distance to the dray is going to be normally distributed, and the angle is not going to be normally distributed, even if we pretend that it is. We have a scenario where we have two different random probability distributions, and the combining of those two probability distributions results in something that's called a Cauchy distribution. A Cauchy distribution is also known as the drunken monkey distribution. The result is that it does not have a finite mean, which means simply that that probability distribution, as you increase the number of observations, does not converge on the true value. So that's the statistical issue, the stochastic issue associated with this. There's nothing we can do about that. We're going to click radial distance and angle, and then we're going to keep that Cauchy distribution stuff in the back of our heads. Prepare ourselves if you ever present something like this at scientific meetings. Somebody like me is going to drill down on that and and give you grief. All right, our observations are single objects, so we're going to click that, and now we click Next. All right, so remember, we recorded our transect lengths in meters and our distances in yards, so we have to specify what we're doing here. So please specify the measurement units for your data. Units of original measurements. Our transect was measured in, well, it says kilometers here. We recorded our transect lengths in meters, so we're going to click that. We want our measurements to be in hectares. Our distances were measured in yards. So yard. Okay, so now we're going to click Next. And we want our area measurements to be in hectares. So we click Next. All right. Okay. This particular menu box is asking us about multipliers. And in a very real way, that applies to us. And we know that our drays are not 100% occupied. Some of those drays were constructed by animals that have since died. There are perhaps some animals that have multiple drays. And the fact is, we don't know exactly what that relationship is. All we really know is that there is a correlation between the number of drays and the number of squirrels, and that's as good as we can do. Now, in studies that I've conducted in the past, instead of looking at absolute animals, we looked at burrows or burrow entrances and then did the population density estimate on the burrows and determined what the density of burrows was. And after the fact, we went in and we trapped the burrow entrances and determined what proportion of the burrows were then occupied or in use. And we did that for not all of the burrows, but for a certain percentage of them. And we were then able to figure out what the probability of occupancy was. So in that way, we were able to then estimate what the true population density of these animals was. We're not going to do that here. We're just going to ignore that. So for our purposes right here, we're not going to indicate any kind of a multiplier. So for example, if we were to specify here that we're doing a survey of nests, we would use that, and then we would have to specify what the probabilities were. We don't know that, so we're just going to ignore it and go down here and click Next. All right, so now we're ready to proceed to our data entry wizard, and we're just going to click Finish here. And now we come up with this glorious window. There we go. So this is just giving us a brief rundown on how all of this is structured, and we'll go through that. Very good. Next. Yep. Next. Yep. Next. Okay. And next. And we're going to click Finish. And now we should get there we go. Okay, so let's open that up like that. We're now ready to start on our data entry. So here then is our window ready for data entry. What we're going to do is we're going to come across the top here and we're going to select the Data tab. And when we do that, you'll end up with some version of this. You may have to click through these various items over here. So for example, you're probably going to end up with just the study area highlighted. You just click on that. or region or line transect and then observation. So this is the window that we want to arrive at. So here we have our study area, our region. We're really not doing anything with that. If we were doing transect across Missouri or across southeast Missouri or whatever it happens to be, then we would concern ourselves with this. All we're concerned with is our line transect and our observations. So let's begin then and set up the transects. We had 1, 2, 3, 4, 5, 6, 7, 8 transects. So I'm going to highlight this value right here for line lengths, and I'm just going to come up over here and this penultimate little icon up here, I'm going to click on that, and that's going to add another line transect. Okay, so this is going to be my second. I want 8 of them. There we go. So I now have my 8 transects in there. Very good. I'm now going to label all of these transects. This first one here, I've already typed in A1. For the next one, I'm going to use A2, highlight the next one. That's B1, and then I have B2, C1, C2, D1, and D2. Very good. Now what I want to do is put in the line transect lengths. All right, let's go ahead and record those numbers. Let me get over here. There we go. So the first transect was 378.7. So 378.7. All right, the next transect was 262.8. 262.8. 403.4. 424.1. 612.6. 437.4. 282.9. And then 273.2. Okay. Now we're ready to enter the data for, or the observations for each particular dray. Okay, so we're ready to input our data. If you'll go ahead and place your cursor right on this first entry right here, and then click this Append New Record After Current button, it'll pop up and give you this blank data line right here. So what we're going to do is we're going to introduce a number of observations here. So I'm going to do that again. Notice now I have 2 lines of data for transect A1. I'll do that just a few more times here. And now what I'm going to do is I'm going to resize my window here. And what I want to try and do is get both my Excel spreadsheet open that has the data, and I can then, without consulting my notes, enter the data more easily. So let me resize the Excel spreadsheet at the same time. There we go. Go all the way up here and then scroll. There's transect A1. And here are the angles and the distances that I want to record. So the way this is going to work, this is my distance here in the first column. and then my angles in the next column. So my distances are 19, 58, 58, and then 68. I'm going to go up over here and put in the angles. I had 80 degrees, 75 degrees, 75 degrees, and 85 degrees. Okay, I'm going to go ahead and type in all of these data off video. When I get to the next transect, I'm just simply going to highlight this point right here and then go here and append a new one, and that gives me numerous new lines for A2. Okay, so I'm going to go ahead and fill in all of these data, and then I'll see you back in a moment. Okay, so all of the data are now entered, and you can see that here. I have it from D2 all the way up to A1. So the first column is the distance, and that's measured in yards, as indicated up here. And the next column is angle, and that's measured in degrees. Okay, so just one quick point. Something I've noticed as I've worked through these data, and that is that on some of these transects, the distribution of distances was very different than on other transects. In some of these, for example, here you can see a squirrel dray was spotted at a distance of 205 yards, here 189 yards. So some transects, the distances were quite large, and on others, the distances were relatively short. So here, for example, C1, there isn't a single distance that's greater than, 70 yards, and the same is true down here. And that could be a couple of things. It might be simply that the habitats were different. It might also be observer error. So, or yeah, I don't know how else. It's not to imply that it's a mistake, but that some observers either have more vision or better vision, I should say, and or were searching more extensively off in the distance. But that's something to keep in mind, and I think that'll reveal itself when we run through the analysis. Okay, so we are now ready to perform the analysis, and what we're going to do, let's see, click the Analysis tab, and so we've just gone over here, click the Analysis tab, and now what we're going to pay attention to is the color of this little globe right over here on the side. When no analysis has been done, it's going to be gray. Once we click the Run button, then that's going to either be red, orange, or green. What we want is green. Let's see what happens. So I'm going to come up here and click this little icon. It's right next to the stop icon, and it's the little running man. So I'm just going to click that, and the system is now working. And I guess it's still working. There we go. We have a yellow ball. Green ball means good, yellow ball means caution, and red ball means, holy smokes, you really boogered something up. Okay, so what we want to do now is we want to look at this analysis, so we're going to click on this little icon here with the magnifying glass. So we're going to look at this in detail. Let's click on it. And now we come up with a series of windows, and we're going to go through some of those windows. We're going to click, we've got the log indicated right here. Let's go ahead and look at the results and see what we can see. Okay, so let's look at our results. What we're going to do is page through a variety of these different results. And Obviously, some of this information that's here is just self-explanatory. Some of it is only going to be of interest to you if you're doing some serious modeling work and you have an extensive background in probability and statistics. So we're going to just glean over or just pass over a bunch of it. Let's go over here to the upper right-hand corner and click on this next button. And that's going to give us some of our basic information. So here it has some index of effort. We have 8 samples, and it gives us, we have a total of 161 observations of Drays, and it's giving an estimate of the width of our transect. And also over here, it's telling us something about the model that it's using to evaluate. And it's using what's referred to as a half-normal distribution. That'll make sense here in just a moment. Let's actually click forward to that in just a little bit. Here are some of the parameters that are going to be used in the development of that model. We're going to skip over all of that. We're going to skip over all of that. Here, well, let's skip overall. Here's what I want to look at. You can look at this function here as the following. On the x-axis, we have a perpendicular distance that's radiating out at 90 degrees from the transect. And on the y-axis, we have the probability of detecting a Dray, if in fact the Dray exists. So these blue bars, this histogram, is actually what we found, and it's broken them up into a variety of distances. So here, from 0 to 20, that's 20 yards, and the probability of seeing a Dray there was just somewhat better than 90%. And it decreases, although it does not decrease monotonically. So if it were to decrease monotonically, then each bar here would be lower than the bar that preceded it. And here you can see that that's not true, and here you can see that that's not true. So in a very real way, two things are illustrated here. One is that if the Dray is directly overhead, you don't have a 100% probability of seeing it. And if the Dray is very far away, you're actually somewhat more likely to see it than you would expect. So this one over here on the left, that's pretty obvious why that is happening, and that's because as we're doing these transects, we're looking left and right off to the distance, but nobody is looking directly overhead. So had students looked directly overhead, they would have then spotted some of these Drays. Now, part of that is also the consequence that on some of these transects we're walking down the middle of the road, or and there is no canopy immediately overhead. If we were out in the forest, we would likely see those. But if you're in Kapaha Park, there are going to be some situations where the tree is directly overhead, and some of those transects would have been missed. Now, what happens here is that this program goes through an effort where it's trying to reduce the bin size. So now instead of looking at roughly 20 yards at a pop, we're looking at somewhat less. And that reveals how serious this issue right here on the left-hand side is. So your probability of seeing a Dray that's at 20 yards is actually much higher than your probability of seeing a Dray that's immediately overhead. And that function, therefore, is not monotonically decreasing. Now, we said that this is a half-normal distribution, and you can kind of get a sense of that here. If this were a normal distribution, this would be a perfect bell-shaped curve, although we're only looking at half of it, right? We're looking from 0 onto infinity, so that's why it's called a half-normal curve. And obviously, it's not perfectly normal because it has this little rise over here. So what has happened in this program is it has introduced some modifiers to this curve. We get this little bump here that's built into the model, so it's not a perfect half-normal distribution. It's modified a little bit with a cosine function or something along those lines. So that's something that we can play with. We can change the modifiers that are used, and we can change what's being used to describe this function right here. And if we do that, we may be able to improve the scenario to where we get a green globe rather than a yellow one. The yellow globe indicates only that we need to be a little bit cautious. So let's go, and here we've divided these things up even more. Okay, that's all fine. What I want to do now is show you this page right here, which gives us our essential result. And here what we have, our parameter over here on the left, that's our density. And we have a density of about 4.5127 gray squirrel drays per hectare. And it gives us the standard error estimate and the coefficient of variation. And what we care about here are the 95% confidence intervals. And the 95% CI ranges from 2.68 to 7.57. And what that tells us is that we have there is a 95% chance that the true density of drays is between 2.7 drays per hectare and 7.6 drays per hectare. So our 4.5 is right in the middle of that. We think that the average, or that the value of drays, the true number of drays, is approximately 4.5, and we're 95% sure that it's going to be somewhere between 2.7 and 7.6 drays per hectare. Now, if we were to repeat this every year using exactly these same transects that we did this time, or if we were to look at other habitats, perhaps Kelso Sanctuary or Mingo National Wildlife Refuge or Trail of Tears, something like that, we could then compare these numbers with the data that we get from there, and we could then see if these density estimates are overlapping or not, and if there is a real difference between the density of gray squirrels in town versus the density of gray squirrels in a more natural setting. We could also compare the density of gray squirrel drays around the SEMO campus versus what you find in a newer part of town, okay, like on the northwest side of town where all those McMansions are. Okay, so there is the final result. There's that given again. Okay, so what we can do now is we can try and improve this situation. Let's go over here to Tools, and let's see, click Preferences. Yeah, let's try. Whoops, I'm in the wrong place. All right, let's go up here to Analysis and Inputs, and go down here to Model Definition Properties. Let's click on that. And here are the adjustment terms, and what we're using is a half normal with a cosine. We can look at that, change that cosine to a simple polynomial or a Hemite polynomial. Let's try that. Well, let's go with a simple polynomial. Let's apply that on our, let's see, adjustment terms. That all looks fine. Let's go back here to our estimate. I think we'll leave all of that. Let's just click OK. Okay, let's click yes there. Very good. Now let's go back to our project browser. And what I want to do now is run this analysis again and see if we end up with a different result. We don't. There you can see the results again. It's essentially just as we uh, had before. Um, let's see. Let's come over here under analyses and let's conduct a new analysis. All right, so there's our original analysis right there. Let's go here to analyses and um, okay, I've played with this a little bit. What I've done is I've started a new analysis here using our data. And I've simply changed some of the parameters of that analysis. So I've gone back in through the analysis window. Well, let's actually view analysis components. Nope, that's not what I want. Let's go ahead and look at that. What I've done is I've changed some of the modeling parameters, and I don't think that's anything that you need to concern yourself with, but let's look what we get here. So that still doesn't look very good. That still doesn't look very good. But you'll notice one of the things that is happening here is that I've now forced it to be monotonically decreasing. So that is part of what's happening here. And when you look at the results, it is just a little bit different. My point estimate is now 3.8194. In other words, I have on average 3.8 Drays per hectare. And my 95% confidence intervals are a little bit different too. So I'm 95% certain that the true value is between 2.3 and 6.3 Drays per hectare. So obviously, if we were doing this for a formal research project, we would go into some detail and try and figure out exactly which set of modeling parameters we want to use to get this. But for our purposes, we're fine either on the initial analysis where we had the orange globe or on this analysis where we have the green globe. This result is closer to the truth than the one with the orange globe, but for our purposes, that really doesn't affect us. So we go to the very end, and there we get our ultimate result. Okay. All right. For your assignment, what I would like you to do is basically just copy what I've done. So open up your distance program, use the Excel spreadsheet that has all of the data on it. The length of each transect is on the far left corner of that Excel spreadsheet. The angles and the distances that you want are in the columns that are in bold, highlighted under each transects A1 through D2. Enter those data, and then once you've got those data entered, run the analysis, and then get your result. What I would like you to turn in is the following. Once you get it all set up, I would like you to turn in a screenshot of the following. I want a screenshot of this particular page right here, okay? And then I want a screenshot of this particular page right here. And the way you can do that is just by using the snipping tool. And the snipping tool is available both in Windows 7 and Windows 10. Here it is right here. There's the snipping tool. If you're using Windows 10 and it doesn't pop up, just in the search bar right here, click snipping. So you would simply click the snipping tool. There it is somewhere. Where the heck is my little snipping tool? Ah, there we go. Okay, so now it's open. I have this little device here that looks like this. I'm making a new one. So all I'm asking you to do is come here and then highlight that part of it right there, and then save that as an image. You can go right up here. If I can get I'm working with two monitors, and there, file, save as. It's going to show up somewhere. Obviously, I have a lot going on at this point. You can save it as a JPEG. Call it your last name, so SCHEIBE, and then data table. Okay, you're going to save that one, and you're going to email that to me as an attached file. And then what I would like you to do is also save that graph. Come on, my cursor isn't behaving. All right, there we go. Oops, I got to go back the other way. There. So save that in the same way, and just your last name and then graph. So turn those two things into me. So you're going to email me your last name, table or data, and then your last name, graph, and that's all she wrote. We'll deal with this in a little bit more detail when we're able to meet again. Apparently the weather forecast now is for some additional snow beginning this weekend through the middle of the week. So let's keep our fingers crossed that we are able to meet. If we don't meet on Monday, the lecture will be a video online. Terrific.